Okay, this is a continuation of lesson 3.3. We're going to work on homework problem number 1 is a good example to see how we should do the homework. Decide whether or not the sequence converges to a limit. If not, find at least one convergence. Subsequence. Suppose that n is 1, 2, goes on as natural numbers. And we have our sequence, x sub n is negative 1 to the n times 1 minus 1 over n. Okay, so if we were to put this in the calculator, again, we make sure that we go to function and that we are in sequence. And then we go to second and list. And this time, in the past, we've looked at sum. We put in sum and then sequence and then put in the argument, but the equation. But here we're just putting sequence. So we just go to 5, and it should just, why didn't it just go straight to, there we go. Okay, so now we're going to put in our equation, negative 1 to the n. So open parentheses, negative 1, close it, and then exponent. So I'm going to raise this up so we can see both. So now exponent, n, and then open parentheses, 1 minus 1 divided by n. Close it. And that looks good. So our variable is n. It's because we're in mode, our sequence mode, our variable is not x right now, it's n. So we're going to start at 1, because that's what we're starting at here, is 1. And let's try, I don't think we need to go so far out as 50, we're going to try 10. Now step, that'll be 1, and hit enter, and this is what our sequence should look like. Well, there's 2 of them in there. Delete one of them, we don't need 2. Okay, so that's 1 over 1n, 1 over n, and 110, close it. Okay, enter. Okay, and we get decimal, so we go to math, fraction, hit enter. Okay, and so here we have at x1 we have 0, x2 we have 1/2, x3 we have a negative 2/3, x4 we've got 3/4, and so on. And so we can see that it oscillates back and forth: 0, 1/2, negative 2/3, 3/4, negative 4/5, 5/6, and so on. So we can conclude, so this is x to the 5th, we can see that's negative 4/5, x sub 6, 5 over 6. So we can say no, the original sequence does not converge to a limit. Converge to a limit. So we need to come up with a subsequence. Alright, so what we can do here is we can go back to our second and list and back to ops and 5. And there's our sequence. So now what we can do is we want to change the step. Instead of 1, so in other words, this, instead of being x1, x2, x3, we're going to go to step 2. And so that produces an x 2n for us. Okay, so our sequence is now x2n. So when we go back to do our sequence again, now we're at a sequence of 2 and hit enter. Okay, and then change it to fraction of 1. Okay, now we're converging. They're negative numbers, but it don't matter. You only need one subgroup, one or the other. So now we've got 0, negative 2/3, negative 4/5, negative 6/7, negative 8/9, 8/9, and it keeps going. So we could keep going with that. So we could play with this a little bit. Go back to second list, ops 5, and instead of 10, let's make this 15. And let's see what we get from there. Okay, and then math 1. So 8/9, 10, 11, negative 12/13, negative 14/15. So it's converging to, what do you think? I'm going to let you figure this out. Negative 8/9, negative 10/11, negative 12/13, negative 14/15. So therefore, this is converging. X to the 2n, sub 2n, is converging to negative 1. Okay, so that is our answer. So even though we were not able to find the original sequence to converge, we were able to, the Bolzano-Weierstrass theorem held for us that the subsequence did converge, and we only need one of them. We didn't have to do the positive numbers. We could just do the negative, and it converged to -1. And so we're done. And that concludes this video.